We have seen how to take the derivatives of the products of functions and the quotient of functions. So now we're going to see how to take the derivative of the composition of functions. So in case it's been a while since you've done the composition of functions, let's review it a little bit. So you're given two functions, f of x and g of x, and we're going to compose g inside of f. And we know this because it's written f of g of x. That's the way that we say it. So what we do is first, you replace just the inside function. So we write f of 5x squared minus 1. And then how function notation works is whatever is in the parentheses here replaces the x inside the function of f. So it becomes 3e, and instead of x, it's 5x squared minus 1. So this is the composition of g composed inside of f. Now we can also do it backwards. We can do what is called decompose a function. And actually in calculus, this is the way that you use it. You decompose functions. So if we're given y is equal to the ln of 3x minus 1, we want to know what is the inside function and what is the outside and the inside function. So what is f of x and what is g of x? So if we let y be f of g of x, again, g is the inside function here. So what is the inside part? Well, the inside part is going to be what's inside the ln. So it's 3x minus 1. And the outside function is going to be the ln of x. And the reason that works is because if we put 3x minus 1 for x, it becomes the ln of 3x minus 1. So what you're going to want to do in calculus is you're going to want to see what is the inside function and what is the outside function. Now, the general power rule is actually a special case of the chain rule, which will come in the following videos. So first, we look at the general power rule because it's kind of the easier chain rule to see. So remember that from before, what's the regular power rule, right? So we just learned the power rule of derivatives first, and that is that if you have x to the n, the way that you take the derivative is you bring the power to the front and you subtract one from the top. Now, the general power rule is that instead of just being an x, it's going to be a composition of a function. So it's going to be something more complex than x. And the way that the general power rule works is that you begin just the same way. So you bring the n to the front, you subtract one from the top, but what's new is you multiply it by the derivative of the function, so u prime. Let's take a look at 3 examples to kind of make sense of that. So we want to differentiate f of x is equal to 5x minus 2 to the 4th. So the first thing you need to do is think about what is the inside function. So the inside part, the u, is going to be the 5x minus 2. That means that f of x is equal to u to the 4th. And that's a function that we're used to taking the derivative of. So f prime of x, the power rule is we bring down the 4, we subtract 1 from the top, but now because u is something more complex than just x, you need to multiply by u prime. So what is u prime? Well, if u is 5x minus 2, the derivative of 5x is 5, and the derivative of 2 is 0. So u prime is 5. And then you just put all that back in. So 4, 5x minus 2 cubed times 5. And then the 4 and the 5 can be combined. So I'm going to have f prime of x is equal to 20, 5x minus 2 cubed. And here's my derivative. Now, if you wanted to, once you get kind of comfortable with the general power rule, you can actually go, you don't have to use the u, but I would really, really advise to actually pick out your u functions because it's going to help you when you do the chain rule in general. Let's do 2 more. So we have y is equal to the square root of 6x squared plus 1. So think about what you might pick as the inside function, and it's going to be 6x squared plus 1. U prime, because we know we're going to need it, is going to be the derivative of 6x squared is 12x. The derivative of 1 is 0. So then I have y is equal to the square root of u. But remember, I can't take a derivative when it's in a radical. First, I have to do the algebra, which is change the square root to the 1/2. And now I can take the derivative. So y prime is going to be, I bring down the 1/2, I subtract 1 from the top, which becomes a negative 1/2, and then I multiply by u prime. Now, because this is a negative power, a negative 1/2, I'm going to bring it back down to be with the 2. So it's going to be 1 over 2. And because it's a 1/2, I can put it back under a square root. So the negative puts it in the bottom, the 1/2 puts it in the radical, times u prime. And actually, remember that this is over 1, so I can just write u prime to square root of u. Now I'm going to put back in everything. So y prime equals, so u prime was 12x, 2 square root of 6x squared plus 1. But this 2 here cancels with the 2 in this 12, which leaves us with the 6. So it's 6x over the square root of 6x squared plus 1. It's nice to simplify it with the u first. That way it's less complex. So when you put the u and the u prime in, it's a little bit easier to work with. Let's do one more. I have g of x is equal to 2 over x squared minus 3 to the 4th. So my inside function is going to be x squared minus 3. So the derivative will be 2x minus 0. So g of x is equal to 2 over u to the 4th. But again, I cannot take the derivative like this. First, I have to bring up by making it a negative 4. And now I can take the derivative. So g prime of x is going to be a negative 8 u to the negative 5 times u prime. But again, I'm going to simplify that a little bit. So because this is a negative power, I'm going to bring it down to the bottom. So the negative 8 and the u prime will stay in the top, and the u to the 5th will go to the bottom, and it becomes a positive 5 because I brought it down. So now I'm going to put everything in. G prime of x is equal to negative 8 times 2x over x squared minus 3 to the 5th. And then I can multiply the 8 with the 2, so negative 16x over x squared minus 3 to the 5th. And again, I like to simplify my u's before. It makes it easier. Here we go.